So last time we discussed the second chapter of this textbook, and I believe we also had a little quiz, right? Let me try to find where the quiz was. It's chapter 2. We looked at the graphs of functions. So if you have a textbook, then you just need to click on the section 2.2, I believe, right? That's where we found the quiz. And the question was dealing with the graph of function. So I think problem number 16 we had for the quiz, right? In exercise number 16, we need to decide if that's a function or not. And the answer is no, it's not a function because there are plenty of vertical lines that intersect the graph of the circle at more than one place. So what you need is to make sure that the vertical line test passes and you have a function when you have a graph. And if vertical line test does not pass, then you don't have a function. That's pretty much all it is. So we worked on the graphs, and I guess that's the key part of the pre-calculus or college algebra class that we're dealing with right now. So I guess the main section was 2.5. That's where we stopped at. And that section was actually talking about graphing. So section 2.5 is where I want to pull some problems from and do. And of course, if you have any exercises in mind, please let me know. We'll do it together. You could just put your question either in chat or ask me out loud so we can do problems that you're interested in. So we have so-called library of functions. And in this library of functions, there are standard graphs, such as a parabola, y is equal to x squared. So if you know this shape, then you can always graph anything that contains that square in it. For example, if I try problem number 51 that talks about a graph of function that deals with 2 times x squared. So if I get a parabola with 2 in front of x squared, and all I have to do is get a parabola which is a little bit narrower than the one above. Why is this the case? Well, because when you multiply your x squared by 2, then you actually double y coordinates, which means that if at the previous example I had for every x some particular value of y, now it's twice. So now we're going to have that same value of x 2 times that y value. So the graph is going to be farther from the x-axis 2 times. So previous value, now it's doubled. And that's what happened, why the graph is going to be narrower. What I'm graphing is 2 times x plus 1 squared minus 3. So the next step I could take by adding 1 to x inside the parentheses, and that will actually bring the graph by 1 unit in the left direction. So the same skinny parabola now will be moved by 1 unit to the left, because when you add in 1, the graph is actually going to be shifted in the left direction. That's another thing we observed last time, which is quite amazing because one could say if you add, you should probably move graph to the right, not to the left. But the answer and the idea is that we actually add one inside the parentheses, which means that this is the first thing we do to x, and that's actually moving the graph backwards along the x-axis, and that's why we have to kind of prepare, and we bring in the graph to the left. So our first step of getting this graph shifted by 1 unit to the right is being done if you think about adding the number to x itself. So you can think of it if you want, but some people just remember if you have inside the parentheses plus, then the graph moves to the left side, kind of opposite to the common sense. And then the last step we do is we bring the graph down because the 3 is subtracted, so that new graph that we produced, and that's actually the graph they're asking us to get when you subtract 3, is going to be moved down because minus 3 from the whole thing means the graph is shifted downwards. So the result is here. I just graphed that function, and the key part is that the lowest point on this parabola will be point with x coordinate -1 and y coordinate -3, which is called vertex. That's a special name that people give to this key point on the parabola with coordinates -1 and -3, the vertex. Once you plot this point, then your parabola just opens up from that particular place. So graphing x squared, the parabola, is here. So how about its friend, the graph of cubic parabola? Y is equal to x to the power of 3, y is equal to x cubed. Well, here we dealing with the exercise like 42 that has the third power of x, so I can graph that x cubed -1 function g of x, or I could just write it as y for convenience, because g of x or f of x you can always replace with letter y, and this will bring the graph of that cubic parabola downwards by 1 unit, because when we subtract 1, we bring the graph down. Same with the previous exercise. When I subtracted 3, I brought that parabola down by 3 units. So if I subtract 1, then I bring the parabola down by 1 unit. And it doesn't really matter if you have x squared or x cubed, the graph of function will be actually having same type of transformations. So I add them to the whole thing, bring the graph upwards, and if I subtract them, then I bring the graph downwards. Other important fact to know that when you have a negative in front of the function, then the graph is gonna reflect through x-axis. So you can imagine yourself a mirror along the x-axis, and if you put a minus, attach a minus to your cube or to squared, the graph is going to just mirror down. So if you look at the parabola y is equal to x squared and put a minus in front, then this graph is gonna open downwards. So if I try to do the problem like 57 here, that actually has a negative sign in front of my x cube. So the graph will be opening down. Now, if I want to put a x plus 1 inside the parentheses, just like in the previous exercise, I'm going to have the graph of that parabola that opens down shifted by 1 unit to the left direction. So this is going to be something that I just produced in here. So you can see that yellow graph above moved to the left by 1, simply because we added 1 in the parentheses. And this is analogous procedure to what I did with a parabola in exercise number 51 on the left side. We also brought our parabola 1 unit to the left because of adding 1 inside the parentheses. So main observation here is that it doesn't really matter what function you have, whether it's x squared or x cubed. Once you have plus 1 inside the parentheses, your graph is shifted by 1 unit to the left. Now, how about the actual exercise 57 that has x plus 1 cubed in the parentheses, and also at the end of it, subtract 1. Well, if you subtract 1 from this entire equation, then the graph goes downwards, right, by 1. So now my cubic parabola will look somehow like that. So the point that I used to have with x coordinate -1 will actually be brought down by 1 unit because of that subtraction of 1 from the whole thing. So key ideas of this section is that transformations of graph happen no matter which function you're trying to graph. And that's why it's so important to know basic graphs of such things as a x to the second power and x to the third power that we considered last time. Well, there are other graphs here that they are dealing with, and the close friend of the parabola x squared is a function, a square root of x. So that's another graph that we can look at, and this is something that appears in exercise like number 48, for example. So in the problem number 48, we can take a look at 1/2 multiplied by square root of x. So what I'm going to do is consider this square root function. And now, since it's multiplied by 1/2, it's going to be closer to my x-axis twice. So the graph is going to be some similar shape to what we have above, but since I took 1/2, then for every value of x, my y coordinate is going to be twice smaller. So the graph is going to be closer to the y-axis since we took 1/2 of every previous y coordinate. So it's still the same shape, but it changed a little bit. So if I try problem like number 58 exercise, it looks like my graph of the square root function above now is going to be multiplied by the negative number and multiplied also by -4. So if you try to think of its graph, then it's going to be reflected through x-axis because of negative sign. So first of all, I can start to think about multiplying it by 4. And if you look at the 4 in front of a square root of x, then you get the values of x quadrupled. So it'll be the graph up higher, but shape is still the same, with it's +4. But if you had a -4 in front, well, then the graph is going to be actually reflected through x-axis, just like with negative in front of x squared, the parabola was opening down because of minus, or with a negative in front of x cubed, that cubic parabola was also reflected through x-axis. So now I'm gonna graph the actual exercise with x -1 in the parentheses. So what's gonna happen with the graph if you ask to put a -1 inside the square root, or you could think of it as if it was in the parentheses? Well, then the graph is gonna shift by 1 unit in the left direction. So the pink graph will be right here. I know that sometimes people kind of wondering why we have to shift the graph to the right rather than to the left. And there is a simple way to check and make sure that this indeed works by looking at the coordinates of point that we just produced on the graph with this shift to the right. The coordinates of the point will be 1 for x and 0 for y, right? All points on the axis have one of their coordinates equal to 0. You can see for y coordinate at 0 because when you draw perpendicular to y-axis, it's actually hitting the origin. And x is still equal to 1 because you're at 1 on the x-axis. So to check and see if that works, I will put 0 instead of y and 1 instead of x in this equation and see if this is gonna make sense, if this is going to work. So if I take -4 and if I multiply it by a square root from, now instead of x I put number 1, would this be correct? Is 0 equal to -4 times a square root from 0? And the answer is yes, it checks, because square root 0 is 0 times -4 is still 0. So I just double checked and saw that point with coordinates -1 and 0 actually worked for this particular equation. So that's our way to double check. Whenever you doubt, you can always see if the answer works. So that's a popular function, square root, that we again put in so-called library of functions that we need to be familiar with whenever you encounter the questions that deal with it. And the last function in that library is a absolute value of x. It's just like a check mark. And last time we also saw these functions in the beginning of this section 2.5. They provide you with a bunch of graphs. So our goal is just to look at them and realize that they all could be graphed using the same type of transformations. So I'd like to do problem number 54 that actually talks about graphing this absolute value function multiplied by 3 in front. So when I triple the function, I have to triple the distance to the x-axis, and when I do this, when I triple it, the graph is actually going to be way closer to my y-axis. So if I triple the y-coordinates for every point, then the graph kind of folds closer to the y-axis, or people say the graph contracts. So it's narrower graph here. And then in exercise 54, I need to do a few transformations to this 3 times absolute value function. So first transformation I can say is in the absolute values, I need to add 1, which means the graph goes 1 unit to the left, just like we saw in the previous exercises, right? So whenever you put +1 inside the absolute values, the graph is moving to the left rather than to the right. And then to get an answer to the exercise with this same graph, -3 times absolute value of x plus 1 with a -3 at the end. So when I subtract -3 from the whole thing, it means I move the graph down by 3 units, right? And it doesn't matter if that's absolute value or a parabola or anything else, the graph simply shifts by this number that I subtract downwards. So that's what we discussed last Saturday, and I guess that's a little bit of a refresher of the story. Now I'd like to move to the next chapter, because 2.6 is a section that deals with word problems only, and we don't really need this for our class. So the chapter 2 is over, and we move into chapter 3 that talks about lines. That's our, I guess, old favorite story, linear equations, or since we learned word functions, it's called linear functions. So let me give a link to the textbook. If you did not have a chance to save it, I can just share this textbook with everyone here in class. So I will put this in the chat, because that's a free textbook that I found online. So you don't have to purchase the textbook for this class. I already numerously shared it, but if someone just added this class, well, here's the textbook that you should, I think, save, and is a good idea by clicking that download key after you found this textbook. So you will have it on the hard drive of your computer. So this way you'll be able to do the homework, right? So anyways, let us look at section 3.1 that deals with finding the equations of lines. And we used to have equation of line in the form mx plus b, where the special word m was dealing with so-called slope, and the b was a intersection with y-axis. So the point of intersection is called y-axis intercept, right? That's very popular in the math Laplace's equation. And whenever you get a line or something that deals with x raised to the first power, then you can always write it in that format with y on one side. But since we learned functions, then y could be replaced with a function f of x, but it doesn't really matter. So, for example, here on the page, example 1, they say that slope of this line is -3. Whatever is multiplied by x is called slope, and 7 is intersection with y-axis or y-axis intercept. They like to call it as b, the y-intercept. So when you have y on one side of the equation, then you got the actual result with a slope and y-intercept. So they discussing this slope and y-intercept number 7 here by making a picture of the graph of this line. So they plot point 7 on my y-axis. So point 7 is here. And then slope equal to -3 means that line is actually going down from that point of intersection with y-axis. And the way they think of the slope that they call as m as a rise divided by run. Did you ever hear that? Rise over run is what the slope is. So they think of it as fraction, and instead of 3, they can write it as 3 divided by 1. So they can see that rise is 3 and that run is 1. In other words, if you start at point 7 on the y-axis, and if you move by 1 to the right, that'd be your so-called run. And then since slope is actually -3, then you go down 3 units along the y-axis, and that's how they produce second point. So using a slope, you can produce another point, and then you connect these 2 points and you get a graph of line. So whenever you want to graph line, you need 2 points. So no matter what line is, once you were able to plot a pair of points, and first point comes from y-intercept and the second from the slope story, then you can simply connect these 2 points and get yourself equation of the line graphed. So in the college algebra class, we care about graphing. That's the key idea on all the chapters of this textbook. And graphing of lines is usually the nicest part, because once you were able to see what 2 points are, then you just connect them with a line and get yourself a nice picture. So let me try to do some exercises here at the end of the section. So in every section of textbook we have here, there is a little bit of a story, and then at the end we have exercises. And I told not to worry about such problem as are you prepared? So the group of exercises with are you prepared, you don't have to worry about. And then vocabulary concepts you can also skip. And for the homework, you should look at problems that deal with a skill building group of exercises. So they started problem number 13. So let me do it. Exercise 13 that says equation is equal, y is equal to 2x plus 3 is here. And there are a few parts like A, B, C, and D that ask for slope of this line. And from the formula that we just considered, whatever is multiplied by x is called slope. And other part of this question is asking about y-axis intercept, and this is number +3. So this enables us to graph the function, the line, and that's a part B of this exercise. So once you put 3 on y-axis, because that's intersection with y-axis, y-intercept, number 3, then you need to use a slope, and people call slope with letter M, always letter M, and this is number 2, looks like, but I can write it as 2/1, so I can use the ideas of this rise over run to get second point and then connect it with the first point so we can get a line. So if I'm gonna run by 1 unit from 3 someplace here, so run, they say, is equal to 1, and then rise 2 units up, so get to someplace here, so rise is positive, so I go upwards, it is 2. How do I know this? Well, because 2 I turn into 2/1, so this way I can clearly see what rise and run are, and this way I can get the second point on the graph of this line, so I will connect points together and get a line, and that's what they want me to do in the part B, to graph this linear function or to graph the line. I guess I'm not going to worry about parts C and D here, because all we need is to graph those lines, and that's about it. So graphing lines is what this section is talking about, and that's pretty much all we need in here. So let me try exercise number 19 that says, how about f is equal to 4? Graph this line. Well, there is no x in it, but this means that x was multiplied by number 0. Notice that there is no x here whatsoever, but just a 4. So where is x? Well, x disappeared simply because the slope of this line happened to be 0. Line with a 0 slope turns out to be a horizontal line. In other words, if you want to graph that line, you just use 4 as it is y-axis intercept, and I put that number 4 on the y-axis someplace up here, and then produce the horizontal line that will look somehow like that, parallel to my y-axis, parallel to my x-axis. I say, you sure this is going to be the line, not just the point 4? And the answer is yes, because the point here has coordinates 0 for x and 4 instead of y. So this is actually pair 0, x is 0 because drawn perpendicular to the x-axis, I had 0 on it, and 4 is for y. And this kind of graph actually stands for the line with equation y is equal to number 4, which is something interesting to think of. And sometimes people can double check it by using pairs or points like they do here in the exercises, to just see that whenever x is 0, then y is equal to 4. And that's the point that we just put here. if x is something else, let's say if x is 5, well, y is 4 because that's what the equation says. No matter what x is, y is 4. So if x is 5, then y coordinate is 4. So here's another pair, 5 for x and 4 for y, just like that. So we get another point, and since this is a line, we connect those points together and get ourselves a graph. So whenever you don't have x at all, this is still giving you equation of the line. And again, to get a graph of linear equation of or equation of line, all you need is a pair of points. And how you get this pair of points, honestly, nobody really cares. So you can either use table, that's what most people like. For various values of x, they calculate y's that correspond to them, or you can use a slope and intercept, and that's pretty much all it is. And notice that this section is pretty short. The section just has a few exercises, and then we have applications that I told you not to worry about. So all you do is just skill building exercises, and you can do a few problems here and not to worry about the rest of the section, because I don't ask you to do exercises for homework that related to this applications. They're like word problems. I know people don't like word problems. I will do some of the word problems eventually, but I guess I don't make you do them for homework. And that's why I would tell you to skip section 2 of chapter 3 of 3.2 section, which means that you can just disregard this section at all, because it has only word problem exercises that deal with statistics like ideas. So you have a bunch of points, like you can see here, that approximated with a line. So that's so-called linear regression. That's what we do in statistics. So this section could be skipped. And then the key section of this chapter will be 3.3, that graphs our favorite curve parabola. So you can see this U-shaped curves, the parabola curves, and the story that we already discussed in the previous chapter. We just talked about having our parabolas moved up or down and contracted or expanded. And you can see on this nice picture, if you take a half of x squared, the parabola is going to be the pink one a little bit wider. So you take that favorite basic function y is equal to x squared, and if you happen to multiply it by 1/2, the parabola gets wider. Or if you happen to multiply this by number bigger than 1, such as 3, the parabola contracts and becomes the black, narrower curve in here. And also, if you start to multiply by negative numbers, the graphs are going to flip or reflect through x-axis. And I guess the assumption that we already saw today in the beginning of the class meeting, and I guess this section just reiterates the ideas of that story. So key point on the graphs is so-called vertex, and that's what we really care about the most, and that's what they actually have here in the exercises. So let me try problem number 11 here, that wants you to graph. So that's a section 3.3, exercise 11, that gives us equation of a function y is equal to x squared -1. Well, it looks like this parabola x squared is now going to be moved down by 1 unit, right? So x squared -1 looks somehow like that. It's a parabola that is shifted downwards by 1 because you subtracting 1 from this whole thing. Yeah, and you can see the graph of that, I think, someplace here in the part C. That's the corresponding graph, and that's what this exercise is asking you about. Find the corresponding graph of the equation, and once I was able to get this shifted by 1, I can see that it's actually part C in here. So turns out that this is pretty straightforward, and one can say, so we're doing the same thing again. Well, not really, because if you try exercise number 16, then there'll be a little bit of a problem because you have x squared plus 2x in it. And that 2x does not really tell you how we should work out this graphing thing. And it turns out that I need to do a little bit of algebra to find where the parabola was shifted. And what I do is actually try to get rid of this 2x. And turns out that there is a way to get rid of it by taking a half of 2, which is 1. And notice if I add and if I subtract number 1, nothing will change with my equation, right? You add number 1 and then you subtract the same number 1. So you actually did nothing with that x squared plus 2x. I say, Alex, so why would you do that? Well, because these first 3 terms here could be turned into x plus 1 raised to the power of 2. And there is still going to be that -1 at the end. Let's see, how do you know that? Well, if you look at the multiplication of x plus 1 by itself by another x plus 1, which is actually square. So whenever you square, you multiply the same thing 2 times. Then multiplying x with x will give you first term x squared. Multiplying last numbers, +1 by another +1 will give you +1 at the end. And then inside product will be 1x or just x. And the product of outside is also going to be 1x, which is also x. So we have 2 of those x's, and that's the middle term. So you can check and see that x plus 1 to the power of 2 is actually turning into first 3 terms of my equation, if you want to double check. And the point is that once you have this equation in the form x plus 1 in the parentheses squared, well, then you can graph it. Remember, whenever you have x plus 1 in the parentheses, it goes to the left. The parabola will be shifted to the left. And then if you subtract 1 from the whole thing, you bring your parabola down. So the graph now is going to be the parabola that has its so-called vertex point here at -1 and -1. And this is exactly part B here. The picture B is the answer for that little exercise. So what I just did, I completed square. And that's not very obvious procedure. So today I just want to practice to complete square so we can get graphs of various little parabolas. So let me try another exercise. How about problem number 15 here? Exercise number 15 again gives me the graph that I have to match, actually equation that I have to basically graph, or they say match with the pictures down below. So here we have equation x squared minus 2x and plus 2 that I can put a little bit farther to the end because that equation needs square to be completed. So same procedure as before. They want me to take a 2 and I take a half of it, which is going to be 1. So I add and subtract number 1. So that's all I need to do. Add and subtract. I need to put minus. Subtract the exact same number, which is a half of what's multiplied by that value of x. So when I add and subtract the same number, my equation does not change, but I'm being able to put these three terms together. So I put x, the first one, squared, and the last number 1, and a minus in between because of a negative in front of 2x, raised to the power of 2. And the rest of it, which is 2 minus 1, will be given me plus 1. And this is it. This is my equation. So if I try to graph it, I already know that if I subtract 1 in the parentheses, then the graph goes 1 unit to the right, right? Whatever we do inside the parentheses, well, just goes opposite to the common sense. So if you subtract 1, it goes to the right inside the parentheses. If I add 1, like in the previous example, then the graph goes to the left. And then plus 1 means I bring the parabola upwards. So that key point, that vertex will be someplace here. And here's the graph. The graph of y is equal to x squared minus 2x and plus 2. So I just graphed that parabola. And I can also see that part G, right, is exactly what I reduced. Part G is here. When you look at the exercise and G, which is a graph of it, you can notice that actually the point of intersection with the y-axis is 2. And notice that plus 2 is exactly so-called y-axis intercept. Just like with lines, whatever number you add to the x containing part is always going to be an intersection of your y-axis, simply because the point on the y-axis has its x coordinate equal to 0. So if you replaced x's with zeros, then your y is going to be giving you just 2, because all x's disappear, and you see that pair or point x equal to 0, y is 2, and that's exactly what I just solved. So whatever number is at the end, that's your intersection with y-axis. So doing this, I can check 13 exercise. So I notice that this is going to be a y-axis intercept, and right away I can see that the graph with y-intercept is probably part A, right? Parabola that has y-intercept seem to be in the picture A, simply because there is one graph here like that, but one is Alex, don't hurry, looks like there is a part F also. So which one of these two graphs I need to consider, because looks like only two graphs have intersection of parabola with y-axis at part either A or F. So how do I know which one I should select? Well, if you don't want to complete the square, you can see the vertex here is -1 and 0. So would this work for exercise number 13? Let me check this out. Or the other +1 and 0 works. So that's another way to guess what the graph is without completing squares. Well, if I have such equation as x squared minus 2x and +1, and if I try to see if -1, 0 works, if graph part A is actually satisfying to this equation, all you do is just replace, instead of letter y, number 0, and instead of letter x, number -1. And once you plug this in your equation, it should give you the true statement. So if I replace x with -1, would this work or not? Well, let's check it out. -1 squared is 1. Then if I have -1 times -2 is +1. So is this going to be equal to 0? And the answer is no. So this is not the point that works. So then the graph is going to be part F, because that's the only choice that left. And indeed, if you try to check that one out, if you replaced x with number 1 here, you will see that 1 minus 2 plus 1 will be indeed equal to 0. So that graph works. So the message is there are various ways to do these problems, but today I want to introduce you this completing of squares process, and that's referring to the next group of exercises. So why don't I try to do the problem number 23. So in the textbook, they have so-called recommended problems, and they like to highlight these with a different color. Like you can see, problem number 23 is in orange, right? And that means they recommend to do this exercise. Well, since they recommend, why don't I try to do this? So exercise 23, I want to complete the square before a graph. So let me copy this here. This is a function y, which is equal to x squared plus 4x and -2 that I can leave for later, right? So this way I can do this process of adding and subtracting the same number. And this number will be a half of what is multiplied by x, which is a 2. So what I need is to add 2 squared, which is 4, and to subtract that same number 4. So this helps me to complete square. So I add and subtract the same number. And remember the reason why? Because first 3 terms always give us a so-called perfect square, and perfect square of x that comes from my first term here, and the number 2 added with x inside the parentheses. And then the rest is -4 and -2, which is -6. And I just produced same equation, but in a form that I can graph it. And that's the idea. So here's the result that we have. So you said that's a +2. I wasn't careful and I copied this. Exercise number 23. Thank you for noticing. So I just miswrote this. I had to put a +2, right? Thank you for noticing. So I just didn't copy this correctly. So what would be the number at the end? -4 and 2 is actually -2. Okay. So that's great that you're paying attention, because otherwise I could just write whatever and people will be always copying it without thinking. So thank you for making sure that I did it right, because you can see that anyone can make a misprint. But now we're in a good shape thanks to your help, and we're going to actually look at the vertex. So what be the vertex of this parabola? Well, now I can see that this is going to be shifted by 2 units to the left because it's +2, so I always go the opposite to what is happening in this parentheses. And then since I subtract 2, then I also go 2 units down. And here's the parabola that they were actually talking about. So somehow like that is gonna look like. So I just graphed exercise number 23 here. Notice that +2 at the end actually is a point of intersection of my parabola with y-axis. And in that, I just double check that this process did make sense. So using the special method of completing of squares is what I'm discussing today. So I'd like to do another exercise in this group, problem number 38, and maybe that's going to be good enough, because I know that completing squares procedure is probably the least popular thing that people are doing in college algebra class, but our goal is to get used to this, and I'll do some problems today, and then next time we'll do some more exercises. So let me write this equation in problem 38, such as a 9 will be brought a little bit to the right, because I want to see what's multiplied by x, which is 6. So I divide that by 2 and I get a 3, which means I add 3 squared and I subtract 3 squared, which is actually adding and subtracting 9. So once I completed the square, added and subtracted the same thing, and I can get this in the parentheses with a x in the first place and that number 3 on the last place, and the whole thing is squared. And these two numbers will actually cancel each other, and that's great. So my equation turns into y is equal to x plus 3 squared and nothing left, so just x plus 3 squared. And this enables me to get a graph. So I just have to put 3 in the left direction, so it's like -3, and here's my parabola, just like that. And if one says, how about checking out if this is right? How about finding the y-intersection of this parabola with the y-axis? Well, someplace up here will be probably number 9, so it does go under this process. So up to 38 is what you should work on your own during the next week at home. So I think it's a good moment to stop, because otherwise it gets a little bit overwhelming. So I'd like to have you do the exercise for a little quiz, so you can just practice graphing the parabola. I'm going to give you something nice to try from the previous group of problems. How about if you do problem number 12? We already done a number of exercises today, so why don't you try exercise 12 for the quiz? I think that'd be a nice exercise, because you don't need to complete square, but just to find the graph of this parabola with a -x squared. So all you need to put in the chat is the letter that corresponds to the graph. Is this A or B or any one of these 8 letters that give us the graph of parabola in exercise 12. So the way we take quizzes, you just put the answer in a chat, in a Zoom chat in here, if it's A or if it's B, so one of these letters, but please don't hurry. Please make sure you don't send this to the whole class. You just send it to my name. So you want to select in this blue rectangle below only Alex, only my name. Don't send it to everyone. Just send it to me. And that's the way we take quizzes. That's how you took quiz last week, remember? So once you get that name selected, my name, you just enter your answer, whatever letter corresponds to this exercise, and then you can enjoy the rest of the weekend. Thank you so much for coming over. So I'm going to stop to record. And again, if you have any questions, if you need a textbook